MS Ramaiah University of Applied Sciences.
Hi students, let us have a discussion on Zener diode characteristics. The aim of this experiment are to study the VI characteristics of a Zener diode, to calculate static and dynamic resistances of a given Zener diode, and to calculate reverse breakdown voltage or Zener voltage of a given diode. Motivation to this experiment are: Zener diode is the most basic voltage regulator. It is used in the chargers of mobiles, laptop and digital camera to provide constant voltage for charging. Let us understand the theory behind the experiment before conducting it. A Zener diode is a special kind of diode which permits current to flow in the forward direction as normal, but will also allow it to flow in the reverse direction when the voltage is above the breakdown voltage. Zener diodes are designed so that their breakdown voltage is much lower, that is less than 10 volts. With the Zener diode connected in the forward direction, it behaves exactly the same as a standard diode, that is a small voltage drop of 0.3 to 0.7 volt with current flowing through pretty much freely. In the reverse direction, however, there is a very small leakage current between 0 volt and the Zener voltage. When the voltage reaches the breakdown voltage Vz, suddenly current can flow freely through it. To conduct this experiment, we need dual DC power supply, multimeters, resistor of 1 kilo ohm, diode models either 1N4007 or BY127, breadboard and connecting wires. Construct the given circuit diagram for forward bias on breadboard. In this setup, change the power supply voltage in steps of 0.1 volt. Note down the corresponding voltage and current from multimeters. Repeat the procedure till supply voltage reaches 1 volt. Continue taking readings by changing the power supply voltage in steps of 0.5 volt till supply voltage reaches 6 volt. Plot the graph between voltmeter and ammeter readings. Calculate the resistances. This is the experimental setup. Construct the given circuit diagram for reverse bias on breadboard. In reverse bias setup, change the power supply voltage in steps of 0.5 volt. Note down the corresponding voltage and current from multimeters. Repeat the procedure till supply voltage reaches 12 volt. Plot the graph between voltmeter and ammeter readings. Calculate the resistances and reverse breakdown voltage from the graph. Figure shows the plotted graph with the readings obtained in forward and reverse bias. Limitation of the setup. We cannot apply DC power supply more than 15 volts as dual DC power supply available in the lab has its maximum range of 15 volt.
Hello students, the experiment name is Zener diode characteristics. Aim of the experiment is to plot and study the VI characteristic of a given Zener diode and to calculate static and dynamic resistance of the Zener diode and to calculate Zener voltage of the given Zener diode. Components used for the experiments are dual DC power supply, multimeters, Zener diode, resistor, breadboard, connecting wires. Before starting the circuit connections, let us see the components used for the circuit connections. This is dual DC power supply which has two voltage source, one is here and one more is here, and each voltage source has two terminals to take a voltage. Red one is called positive terminal, black one is called negative terminal, and here it has some knobs. These two knobs are used to vary the voltage. This is for a coarse variation, this is for a fine variation, and by using this knob we can set the current. Multimeters. This is a multimeter, it is used for a multiple purpose. For example, this is used to measure a AC voltage, to measure a DC voltage, to measure a DC current, and also to measure the resistance of any given component. Multimeter can be connected to the any part of a circuit or any point in a breadboard by using these two terminals. One terminal is called a positive terminal which is red in color, another terminal is called negative terminal which is black in color. This is a Zener diode, it is a two terminal device, it has two terminals as P and N. If you see this diode, one end is black, that is N terminal, another end is P terminal. This is a resistor, it has two terminals and it is a 1 kilo ohm resistor. Its color code is brown, black, red. Resistor is used in this experiment to limit the current to the diode. It is a breadboard, it is used to connect the components of a given circuit. These are the connecting wires which are used to connect the different components on a breadboard. Let us begin with the circuit connections. First we start with the Zener diode forward bias circuit connection. This is the positive terminal of a voltage source. Take a wire and I connect to the positive terminal of voltage source, and which is connected to the resistor one end. This is a resistor which I am connecting in a breadboard. So this is the positive terminal of a voltage source which is connected to resistor one end. Resistor another end is connected to the ammeter positive. So this is a multimeter which I am using as an ammeter for this experiment. So this is the positive terminal of a ammeter which is connected to the this I am connected to the resistor one end, and this is a negative terminal of an ammeter. The negative terminal of an ammeter is connected to the P side of a Zener diode. So I will take a wire and connect to the negative terminal of ammeter which is connected to the diode P side. So this is a diode, Zener diode. So I will connect this somewhere in the breadboard. If I connect like this end is a P, this end is a N. Since negative terminal of ammeter is connected to the P side of diode, I am connecting to the P side, and N side of diode is connected to the ground. So I will take one more wire and connect to the N side of a diode which is connected to the this end is connected to the ground. So I will take this first row as a ground. So I will connect to the ground. Negative terminal of the voltage source is connected to the ground. So this is a negative terminal of the voltage source which is connected to the ground. Ground is the first row of a bottom line in a breadboard. Now you have to connect a voltmeter. I will take one more multimeter which I will use as a voltmeter. This has two terminals, one is black which is called negative, one is red which is called positive. The positive terminal of the voltmeter is connected to the P end of the diode. So this is the positive terminal of voltmeter which is connected to the P end of the diode, and negative terminal of the voltmeter is connected to the N end of the diode. So this is the negative terminal, this is the N end of the diode. I am connecting in the breadboard. this completes the forward bias Zener diode circuit connections. Now we will take some more readings. So before turning on this dual DC power supply, you should keep voltage to a minimum value and current set to a maximum value, and this multimeter as we have used as an ammeter. So bring this knob to a DC ammeter position, that is at a 200 micro, and this multimeter as we have used as a voltmeter, bring this knob to a DC voltage or DC voltmeter position, that is 200 milli DC volts. Now turn on the dual DC power supply. This is input voltage, this is the voltage across the Zener diode, this is the current through the Zener diode. Now I will vary the input voltage in terms of 0.1 volt up to 1 volt, and after 1 volt I will vary the input voltage in terms of 0.5 volt up to 6 volt, and I will note down corresponding voltage and current reading from the voltmeter and ammeter respectively. For example, if I make input voltage as 0.1 volt, this is my ammeter reading is around 0.1 microamps, and the voltmeter reading is around 103 millivolts, which I will tabulate in a given tabular column. Next, if I vary the input voltage as 0.2, now corresponding current is 0.2 microamps, and this voltmeter is showing a reading as one space dot, which indicates that its range has been finished. So I have to change its knob to next level. Now I am getting a voltage reading as 0.216 volts. I will tabulate this reading also in a tabular column, and I will vary this input voltage so on up to 1 volt in terms of 0.1 volt, and after 1 volt I will vary the input voltage in terms of 0.5 volt and tabulate the readings in a tabular column. Now we have finished with the Zener diode forward bias circuit connections. Let us begin with the Zener diode reverse bias circuit connections. This is the circuit connections of Zener diode forward bias circuit, and now we will start with the Zener diode reverse bias circuit connection. If you see the circuit diagram, there is a very small difference between forward bias and reverse bias circuit, that is a diode direction. So this diode is in forward bias. If I remove this diode and if I reverse the diode and reconnect in a breadboard like this, this is the circuit connections for a Zener diode reverse bias. Now we will take readings for a Zener diode reverse bias circuit. So before turning on the power supply, as usual we will make voltage to minimum value, current to maximum value, and we will set this ammeter to a 200 micro position, this voltmeter to a 200 milli position. Now turn on the power supply. Now I will increase this input voltage in terms of 0.5 volt and vary up to 12 volt. I will note down corresponding ammeter and voltmeter reading and tabulate in a tabular column. For example, let us make input voltage as 0.5 volt. For a 0.5 volt of input voltage, I am getting ammeter reading as 0.5 microamps, and multimeter is showing out of range. So I will shift it to next position. We are getting a voltage around 0.515 volts. We will tabulate this reading in a tabular column. Next, we will vary the input voltage, make it as 1 volt, and corresponding current is 1 microamps, and corresponding voltage is 0.99 volts. And if I vary the input voltage like 1.5 volt, then I will get, I am getting a current of 1.5 microamps and 1.542 volts. We will vary this input voltage in terms of 0.5 up to 12 volt and note down the corresponding reading in a tabular column. Now we have finished with the Zener diode reverse bias circuit connections, and we have noted reverse bias readings in a tabular column. Based on these readings, we will plot a VI characteristic of a Zener diode.
At MSR UAS, we spark your imagination unlike any other.